Okay, so back to our notes on part 2 of this video. We already said that a system of linear equations is just two or more equations working together. So what's a solution to a system? We kind of just discussed that in the other video. What is a solution to a system? The coordinate, the answer that works for both equations in the system. All right, a solution to a system is the answer that works for both equations in the system. And if you have three equations, then it has to work for all three of them. Now let's talk about consistent, inconsistent, dependent, and independent. Okay, so let me do this. Okay, so here's a picture of the wall that we have right there, the word wall. And we need to understand what the word consistent means compared to inconsistent. So check this out, guys. Consistent compared to inconsistent systems, all right? So let's first look at a consistent system. What does that mean? It has an answer or infinite answers, okay? So we kind of, on the first video, we graphed two lines, two equations, kind of like right here, you see, sorry, it's blurry. You have two lines graphed. This is called a consistent system because it has an answer, right? This one over here is also called a consistent system. Even though it doesn't look like two lines, it's actually two lines that land perfectly on top of each other. We'll get to that in a little while. But right now, what I want you to understand is that consistent means that there is an answer. Inconsistent means that they have no answers. It says right there, have no answers. They do not intersect. They are parallel. Now think about this. Let's say I gave you two equations, yeah? Let's say that this was the system that I gave you. Y equals negative 2x plus 4 and y equals negative 2x minus 2. Believe it or not, that's this graph right here. If it crosses at 4, it goes down 2 over 1, goes down 2. Oh no, that's wrong. Okay, my bad. Let's just pretend that both of these represented with these. If you were to graph both of them, you could already tell that both of these guys have the same slope. And we already learned from before that if the equations have the same slope, what are they? Parallel. So if they're parallel, that means that they're not going to cross. And if they don't cross, then how many points do they have in common? Zero, none. So this is what you call an inconsistent system, because if I told you to solve this system that had the same slope, you would just say this, no solution. Does that make sense? Because you cannot find the answer that works for both, because when you graph them, this line is representing the infinite amount of answers of one of them. This one's representing the infinite amount of answers of the other. If you have the same slope, you know they're not going to cross, so you're never going to have a point in common that they're sharing. So it would be no solution. Does that make sense? So consistent systems, they have an answer. They do cross. They do cross. Inconsistent, they don't have an answer. Why? Because they don't cross. Now, let's take a look back at the ones that do have answers. There's two types of consistent systems. There's consistent independent, which means they have one answer, one point in common. And there's consistent dependent, which have an infinite amount of answers. Why? Because they're the same line. They land on top of each other. Okay? So let's say, for example, I had the equation y equals x minus 2. And then I had another equation y equals, or let's say 2y equals 2x minus 4. And I told you guys, this is your system. Graph it and find your answers. Well, in order for you to graph this bottom equation, you'd have to change it to slope-intercept form, and you would divide by 2, divide by 2, divide by 2, and guess what? You'd end up with the same equation as the one above, right? So if you were to graph it, you'd end up with the same exact line. So how many points are there in common in those lines? All of them. So right there you would say all real numbers, not all real numbers, infinitely many solutions. Infinitely many solutions. You can't say all real numbers because it's a specific amount, or specific numbers, but there is an infinite amount of answers. Yes? And of course the easier one to understand is the consistent independent, because those they cross and they intersect at one point, that point right there, and that's your only answer that exists. So how are we going to memorize the difference between consistent, independent, and dependent? All right, ladies and gentlemen, what does it mean to be independent? If I say you're independent financially, what does that mean? You're independent financially. You take care of yourself. You work, you buy your own food, you pay your own rent, right? You yourself, independent, right? Independent. How many people are supporting you if you're independent? Just you, one. That's why right here, consistent, independent, that's one answer. Now, if you're dependent on your parents to survive financially, what does that mean? You depend on you need them to pay for your rent, to pay for your food, to all this stuff, right? So it's kind of like if they're carrying you. So same thing here, you have a line, and then you graph another line that lands right on top of it. It's dependent because they land right on top of it. Yeah? So consistent, independent, yeah, one answer because independent means one. Dependent, it's like if they're carrying you, so it's one line right on top of the other, it's the same line. So I explained this down here back in our notes. Consistent, that means that it has a solution or solutions do exist. The lines will have points in common. There's two kinds of consistent. There's the independent, one single answer, dependent, infinite answers. Inconsistent, there is no answer. They do not intersect, they're parallel. The lines will not have any points in common. Let's do an example up here. Oh no, what else does it say? Sometimes you don't even have to graph. If you are rewriting the equation in y equals mx plus b form and you notice that only the m values are the same, you could conclude that they're inconsistent. Why graph it if you already know they're parallel? They're not going to intersect. So you know that they're inconsistent. Okay, but if you're rewriting it in y equals mx plus b and you get the same identical equation, everything's the same. You're talking about y equals 2x plus 3. The other one becomes y equals 2x plus 3. Everything's the same. That means you have the same line, which you would have an infinite amount of solutions, which you could say that it's consistent dependent. So let's take a look at number one right here. Is the first equation ready to graph? This top one. Yes, it's in y equals mx plus b form. So that crosses at -2. You put a dot right there. What do you do from that dot? Down 3 over 1. So that would take you to the edge. Over 1 is right there. You always go down if it's negative, go up if it's positive. You're going down 3 over 1. That's your point. And you could extend this the other way by using the pattern backwards. Up 3 over 1, up 3 over 1, up 3 over 1 would be off the graph. So there's your line. Let me go for the bottom line by first rewriting it in slope-intercept form, subtracting 2x, subtracting 2x. You're going to have 3y equals -2x minus 6. And then we're going to divide everything by 3. Divide by 3, divide by 3, divide by 3. You're going to end up with y equals -2/3 x minus 2. That's your second equation, but now it's ready to graph. Where does that cross the y-axis? -2 also. It crosses at that same point. What do I do from that point? I go down 2 because it's negative over 3. 1, 2, 3. I end up right here. How did I get there? I went down 2 over 3. So ladies and gentlemen, we have enough points and we already see where they're going to cross, right? So let me draw my line, put arrows on it. That's the red line. Let me go to the blue line and draw my line. So if the blue line represents all my answers of the top one, and the red line represents all my answers of the middle one, of the bottom one, then if I'm trying to find the answer that works for the entire system, what would my answer actually be? 0, -2. That only point that they have in common. Now, we have the point. What should we do? What we should do is to take the x value of 0 and the y value of -2 and double check it. If you have extra time on a test, you could plug in 0 right into the x value of your first equation, plug in -2 into the y value of the first equation, and you'll see that it gives you a true statement. -2 equals 3 times 0 minus 2. Yeah, -2 equals -2. It works for the top one. You double check the top. If you plug it into the bottom, it'll also work. So you should graph them, find your point of intersection, and then double check them if you have time.